upon the various processes like casting, forging, extrusion. Extrusion I will touch today, but casting we have done in detail, and we have also studied. We have also touched what is turning, what is milling, various machining processes. Now I just wanted to show you the Word file about the forging. Have I uploaded this in the classroom? Any idea? Forging of metals? Anyone is aware?
Yes, sir. Forging was done in the last lecture.
No, no. Have I uploaded on the classroom these notes?
No, no, sir.
No? Okay. So I'll upload it. Presentation as well as notes also. Presentation we have done. Forging. So this is like, how to write the answer, that is ideal answers. So the question is explain with neat sketches what is the purpose of flash and gutter cavities in closed die forging operation. So flash means whatever the extra material that comes along with the parting line. So that is what is called as the flash. So this is the parting line. So along this there will be a flash. As I told, in forging you cannot inject the exact quantity of the material. So there will be some surplus material, some extra material. This is sometimes also called as the slug, or in case of injection molding or blow molding, or rather blow molding, we call it as a preform. Or in powder metallurgy also it is called as the preform. That is, it's a kind of a raw material for powder metallurgy or for blow mold. So that slug is kept in between the two dies, and it will obviously have some extra material. So when the dies are closed, the extra material will come out along the parting line, and that is what is called as the flash. Because if the material is not sufficient, if the raw material is not sufficient, then the component will not be proper. So this is how you get a flash here. This is the cavity which you are going to get in forging, and this is the explanation. So please go through it once I upload it, and you will have an idea how to write an ideal answer. Explain the causes and remedial actions for defects in forging. So what are the different defects and what are its causes? So more or less some defects are common in castings and forging, like you have warping of the part because of the temperature. You have cold shuts because the two fronts they do not meet at the same time. Then you have improperly formed sections. So these are the some common defects, and the most common defect in forging is the cracking because of uneven temperature across the surface and at the core. Then explain 3 rules of upsetting with neat sketches. So what are the rules for upsetting? Upsetting is the kind of the forging process. Explain working principle of hydraulic press with neat sketch. So wherever it is mentioned that neat sketch means you have to draw a sketch. So this is what is your hydraulic press. Hydraulic press is used, remember, Broadly, it is presses are classified into hydraulic, mechanical, and many others. So broadly, two important types, that is hydraulic and mechanical. In mechanical press, the speeds are very fast, strokes. That is, whenever you want mass production and higher production, or whenever the production rates are very high, and whenever it is speedy production, that time you go for mechanical press. Tap, 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 tap. So we are talking about, you won't believe, but there are high speed presses, and you get as high as 2000 strokes per minute. These are common, 2000 strokes per minute. So you can imagine, how fast it is. Tap, 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 tap. I mean, by the time I talk, you know, this the press will complete the 2000 strokes in a minute. Whereas as against the hydraulic press, the speeds are not fast. It moves slowly. You can control the speed, you can control the pressure, you can control the force, and generally they are used for drawing purpose. Hydraulic presses, they are used for drawing kind of operation. Like suppose if you want to draw a cup or a bucket, like चाय का cup और bucket, जो नहाने के लिए हम लोग यूज करते हैं. So those kind of components are drawn components where mechanical press cannot be used, because you cannot have that much slow speed in mechanical presses. So hydraulic presses, now in the first case, now this is your cylinder and this is for the piston, and you have a fluid here. So fluid gets seen from here and it acts on this surface and it moves the piston. Now this ram of the press is attached to the piston. So now in the first figure, where the piston will move, whether the piston will move up or piston will move down, can anybody tell me in the first figure where the ram will move? Ram will move up or ram will move down? I'll share the picture. Hello. In this figure 1, where the ram will move, whether the ram will move upward or ram will move downward.
Down, sir.
Sorry, speak
Down.
loudly.
Down, down.
Down. Who is this? Chirag, is it?
No, sir. So I think it will move up.
Who's? It will move up. See, because the fluid, the pressure is from here, okay, and the fluid or the liquid or the oil which is here in this chamber, it is coming out. So there is no oil pressure from this side, and there is a oil pressure over here. So obviously it will move up, isn't
But
it?
it is written there. The motion
Hello?
of the ram will move up.
Sorry?
Then it is written there. The
It is
directions are
written
given.
there. It is written there. The arrow is also shown. That motion of the ram, it is moving up. Where it is written?
So
Motion
there,
of the
there.
ram and the upper, it is up. No, here it is shown. What is written? What you are telling? A higher pressure of the fluid below the piston than the fluid above it causes the piston to rise. I didn't get what you are talking about.
So the
Hello?
direction is already given now that it will go up.
Even though I was just asking, and even though the direction is shown, even though it is written, I received one reply that RAM will move down. Barabar na?
Yes, sir.
Somebody replied that it will move down. Anyway, so because of the fluid pressure, there is no harm. ऐसा नहीं है कि we are. I was also in the same boat when I was student. So even if the answer is wrong, ऐसा नहीं कि I will feel bad or उसके ऊपर हंसने का ऐसा नहीं है. हाँ? So please feel free to share. Please feel free to ask your doubts. So nothing like that. So here now, see now these are the die which are attached. So generally this lower die is fixed and upper die is moving. Okay, and then the component billet bolo or slug bolo that is kept here. Now here the fluid pressure is like this. Okay, so there is something called as the wall, 3x2 wall, 5x2 wall, 4x2 wall. So those walls are over here, and those walls control the flow of the fluid. Those walls control the flow of the fluid from here, and it will control the direction of the piston. So this is upper die, this is lower die, and this is what your workpiece is, which is kept. Okay, so it goes down, and then that particular shape of the cavity in the die uh, will come on the workpiece. Okay, so now here you cannot have exact quantity of the raw material, so you have to keep little extra, and that's why the material will ooze out or material will come out along the parting line, and that is what is called as the flash. What is forgeability? Forgeability means like with ease uh, you can forge the material. That is what is called as the forgeability. मतलब some materials can be forged easily, some material cannot be forged easily. Like suppose if I talk about cast iron, so the forgeability of the cast iron is nil or zero. SAE 8620, that is what is very good, forging steel. So forgeability means it is the ease with which a particular material can be forged. Forgings are inherently stronger than castings. It is true, because it gets strengthened. Okay, there is a refinement of the grain, refinement of the microstructure. The grain is continuous throughout the part, right? So that's why they are more reliable, they are less costly also. The process is also very fast. Only the die cost, initial die cost, that is what you have to invest. But then the designer or the manufacturer, he checks the return on investment. That is, if he is investing in the die, what is the minimum quantity that he should produce so that he can get the returns, or he can get the investment back which has been invested in the die. Then there is something called the forging hammer and press. So press is different and hammer is different. Please, hammer मतलब जैसा कि हम लोग, you might have used hammer in your first year, but unfortunately it was online. Hammer का मतलब हथौड़ा, बराबर है ना? तो in house you might have used hammer, or you might have seen at least the people who are using hammer, people who are doing hammering. Okay, so forging hammer, same thing. So you have a hammer, but it is not being operated manually, it is done automatically. Okay, electrical hammer or mechanical hammer, thump 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 thump. Okay. Whereas a press is a kind of a machine. Okay, so press में कैसा रहता है? There will be upper die and lower die. Remember, there will be two dies, and the upper die will be movable, and whereas lower die will be fixed. Whereas hammers में there is nothing like die. You have to hold the components with the help of a wrench, or with the help of a something called as a pakkad. Okay, you have to, or tong, with the help of a tong you have to hold the component and then keep on hammering till you get the shape, which we have seen in forging of hexagon or in forging of square, isn't it? So that is by hammering. Okay, whereas in presses we use dies, upper die and lower die, and whatever the shape is there in the cavity of the dies, that shape is reproduced on the component. And there are many other differences, so you can definitely go through this. Open forging and closed forging. So open forging, that is hammer, what we were talking, that was your open forging. Open forging is also called as the open die forging, and closed forging is also called as the closed die forging. Okay, so in open die forging, the material is not enclosed. Okay, it remains in open state. That's why it is called as the open die forging. Okay, so the metal is altered as the dies hammer. Okay, so you are altering the shape. Remember the example of hexagon. Remember the example of chisel, what I gave. So that's an example of open die forging. Okay. So this I'll upload it today. If you have any doubt in that, you can definitely ask me. Okay. I will quickly go through extrusions. Now some students, they were confused that how do you get hollow in the extrusions. So that is possible, but the extrusion dies become expensive. Hmm. So let us quickly go through the extrusion. So here you have RAM, and this is a die, that red color ka die, and then the raw material is called as a billet, or it is also called as the slug. Billet means it's a slug means if the quantity or if the weight of the component is small, then it is called as the slug. Billet means if the size of the raw material is more, if it is bigger, then it is called as the billet. Billet का क्रॉस सेक्शन एरिया is more and इसका लेंथ भी ज़्यादा रहता है. Okay, so billet is put or it is loaded inside this cylinder, and then it is pressed by ram, mostly by hydraulic actuation, and then there is a die of the desired shape. Like suppose if you want a circle, then the cavity in the die will be circle. If you want hard shape, then the cavity inside the die will be hard shape. Generally, the dies, these extrusion dies, the dies which are used for extrusion are called the extrusion die. Dies which are used for closed die forging, they are called as the forging dies, and so on. So because of this pressure, this billet is pushed and it is extruded, and it takes the shape whatever the cavity is cut inside the die. Generally, these cavities inside the dies are wire cut, because these dies are subjected to the temperature and they are subjected to the wear, because the hot material is flowing inside the die. So they tend to erode the die. They tend to erode the die because of the friction, because of the wear, because of the temperature. So we use the general material for the die is hot die steel. In the market, it is available in the grades of H10, H11, H12, like that. And then it has to be hardened. And once you harden, then your conventional machining process fails. So you need to do wire cut. Okay, wire cut, and you cannot finish the profile before hardening and send it for hardening, because in hardening there are distortions, the finish gets damaged. So that's why what we do rough machining by milling or by any other process. Then we send the die for heat treatment, that is mainly for hardening, and then we do finishing by grinding or by wire cut or by EDM. Wire cut is employed when it is through and through, if the cavities are through and through. If the cavities are blind, then you cannot go for wire cutting. You can go for EDM. But among grinding, EDM, wire cut is fastest process, and it gives quite a good accuracy. It depends whether it is single cut, double cut, three cut, or four cut wire cut machine. Hello? Chirag, I hope you are understanding.
Yes, sir.
Okay. These are the few components. Like now, this is a hollow extrusion. For this particular section, you will have a die of this shape through which the material will be extruded. Here also you will have die of this shape. Either you can have hollow before, or you can use a hollow component raw material, or you can even extrude also hollow. You can extrude hollow, that is you can push a rod in the center and you can create a hollow in the extruded product by pushing a rod in heated condition. So this is how the raw material is prepared. Like you have long pieces that is called as logs. These long pieces are cut by sawing operation, and these are called as the billets. Then these billets are heated, preheated, so that it can be extruded easily and low pressures are required. Then this is followed by extrusion in extrusion press, and you get the desired product. This is how the process is. After extrusion, the parts are inspected whether it conforms, whether the product conforms to the size and shape. Then since the extrusions are long, and there are difficulties in transport, so they are cut to length so that it can be transported easily. Then aging is done for strength purpose. Then if any surface treatments are required, like say anodizing or say painting, anodizing is usually done on aluminum and magnesium. Painting, that is components has to be painted, spray painting below or manual painting below or deep painting below. Fabrication, or if the part is to be welded, or powder coating. Powder coating, any material can be powder coated, and there are many colors you can get it in powder coating. Generally the black powder coated components are popular. After this surface treatment, the products are packed and they are sent to the customers. So extrusion is classified into broadly classified into two categories, that is hot extrusion and cold extrusion. Again, I am telling that cold extrusion doesn't mean that component or the raw material is not heated. Cold extrusion doesn't mean that the extrusion is done in cold condition or it is done in room temperature. In cold also the material is heated, but it is heated below low crystallization temperature, raw crystallization, that is below 763 degrees Celsius. Whereas in hot extrusion, the component is heated above recrystallization temperature. Right now you just remember low crystallization temperature, and crystallization temperature is nothing but where it is the temperature at which the process of crystallization starts. And this you learn in metallurgy. I don't know in which semester you have, but whether it is hot or cold, in hot, what you have to remember, that the temperature is more, in cold the temperature is less. Okay, and since the temperature is more in hot, so any hot component, suppose if it is subjected to air, then it gets oxidized. Since it is in red hot condition, in from the environment, it will capture or the component will react with oxygen, and you will always get a layer of oxides on the surface, that is iron oxide if you are extruding iron. If you are extruding aluminum, you will get a layer of aluminum oxide on the surface. Okay, so this aluminum oxide or these layers on the surface, you need to clean it. So therefore, hot extrusion is always followed by some kind of machining process, some kind of finishing process. Whereas in cold extrusion, there is no oxidation, or if at all oxidation takes place, it's quite less. Sorry, second thing is, in hot extrusion, the pressures or the forces which are required are less. In cold extrusion, you need more pressure or more forces. Again, in cold extrusion, you have forward and backward. In forward, again, it can be done by hydrostatic, and backward cold extrusion can be done by cold extrusion forging or impact extrusion. Okay, so this is, there is two more kind of extrusion, that is direct and indirect. So this is what is your direct extrusion is, where direct is also called as a forward extrusion. So where your ram is pushing the pellet material to the die. By default, it is always a direct or a forward extrusion. If now this is what is your indirect extrusion is. Indirect extrusion. So in indirect extrusion, the ram has hollow. The ram has hollow, and through which the material will be pulled in indirect extrusion. So this figure itself is self-explanatory how the indirect extrusion takes place. So the hollow ram containing the die is kept stationary, and the container with the billet is caused to move. Okay, friction at the die only. There is no relative movement so there is no relative movement at the container wall. That is this container wall, and hollow ram, it limits the applied load. So these are some advantages of the indirect extrusion. But as I said that there is a limitation on the applied load. So there are constraints on the product which can be extruded by indirect extrusion. Machine setup, tooling's requirement are high, like hollow extrusion. Suppose if you want to produce, then again tooling requirements are much more. There are chances of more surface defect, and that's why generally indirect extrusion is not preferred. Then this is some mathematics here, which you can skip from examination point of view, because there will not be any numericals. So how do you calculate the extrusion ratio? Your entire press, the selection of the press or the die design, it depends upon the extrusion ratio. What is the extrusion ratio? The extrusion ratio is defined as the ratio of the area of the works cross section to that of the extrusions cross section. मतलब initially कितना था and बाद में कितना हो रहा है. That is what is called as the extrusion ratio. Like initially, suppose my workpiece diameter is 50 and or say 40, and मेरा बाद में after extrusion, suppose if I want diameter 10, then my extrusion ratio will be 40 upon 10, that is 4 times. Okay, so it depends whether this 4 times ratio is possible or not. What kind of pressures, what kind of presses will be required, what should be the capacity of the press. So that depends on this. So this is most important KPI, key performance indicator, that is extrusion ratio. So it is the process done at room temperature, but don't write room temperature. Generally, it is below recrystallization temperature. See, they have mentioned here that it is slightly at elevated temperatures. Now, the material which requires higher temperature, they definitely cannot be cold extruded. So, which material can be easily extruded, cold extruded? Those are the lead, which are softer, aluminum, which are softer as compared to steel. Lead, aluminum, copper, titanium, molybdenum, vanadium, steel also, but preferably softer. Then, as I told morning, we always take in hand our collapsible tubes for toothbrushing, aluminum cans, those are extruded, cylinders, even the gear blanks, that is gears, can be extruded. See, there are many processes for each and every component. If I talk about, say, gear you can extrude, or with the teeth, I am talking with the teeth, and even the bore also can be extruded. Gear can be cast, gear can be forged. I hope you know what is gear is, which is used for. Chirag, can you tell me what is gear is? Are you
No
there?
idea, sir. Yes,
Gear,
sir.
gear which are used for transmission purpose, power transmission. गियर बॉक्स तो मालूम है ना?
हाँ, गियर बॉक्स मालूम है सर.
हाँ, तो गियर बॉक्स में हम लोग गियर यूज करते हैं ना फॉर ट्रांसमिटिंग द पावर.
Yes, yes, sir. Yes, yes.
हाँ,
Yes.
सो दैट
Understood, sir.
गियर्स, उसमें
Yes,
ऐसा
sir.
टीथ रहता है ना, इट्स अ
Right,
टूथ,
right, sir.
दैट इज व्हाट इज कॉल्ड एज अ गियर. व्हाई डू यू से नो?
सर मुझे लगा प्रोडक्शन प्रोसेस का कुछ अलग गियर रहेगा.
Gear, it's a gear wheel, it's a round wheel having teeth
Yes, sir.
all
Understood,
over,
sir.
okay, having teeth. So what I was telling, gear can be cast, मतलब कास्टिंग से भी बना सकते हैं, एक्सट्रूजन से भी बना सकते हैं, फोर्जिंग से भी बना सकते हैं. एनी अदर प्रोसेस यू कैन थिंक ऑफ फॉर गियर? एनीबडी प्लीज टेल. पेडनेकर, डिसोजा.
Chipping processes.
हाँ, कौन सा?
Chipping process.
Chipping. Chipping will be slow. You said chipping or shaping?
Chipping means using a cylinder, then milling machines and various machines you can.
You can do it on milling machine, but not by chipping. You can do it by milling, then you can do by shaping also, and you can do by powder metallurgy also. Okay, so depending upon the accuracy what you want, depending upon the quantity, depending upon the speed, you have to select. As an engineer, mechanical engineer, you have to select the process. Okay, how you are going to get the returns, that is, see, remember, finally everything is counted in terms of money, isn't it? How much I am going to get the return, बराबर है? Everybody has money, हर एक के पास पैसा रहता है, लेकिन देने का क्या, नहीं देने का, बराबर ना, वो हम लोग सोचते हैं. अगर इसको देंगे तो आई एम गोइंग टू गेट अ रिटर्न, मोर रिटर्न, 10%, 15% ज़्यादा मिलेगा, सो डेफिनेटली नोबडी विल हेजिटेट टू गिव. लेकिन सपोज अगर मैं इसको देने वाला हूँ और पैसा, फॉरगेट अबाउट इंटरेस्ट, आई एम नॉट गोइंग टू गेट द, आई मे नॉट गेट द money back also, principal also, then people will not, or people will hesitate to give the money. Same industrial policies ऐसा ही रहता है. अंबानी बोलो, महिंद्रा बोलो, एवरीबडी. ऐसा नहीं कि देर आर बजट कट्स और बजट थ्रेट्स. दे ऑलवेज ask for the return on investment, that what returns I am going to get. Am I going to get 10% or 15%? Then only I will think of investment. If you are going to give me 6% returns, then I will put it in a fixed deposit. घर बैठ के without any tension I am going to get. or if you are going to give 8%, so 8% भी आजकल mutual funds or somewhere you get. Okay, so
Sir,
yes, sir.
so which process is more preferable to make that gears?
For the gears, generally gears are forged. That is a good process, forging, because you can get almost a finish, and it is a trade-off. Like powder metallurgy also you can do here, but then powder metallurgy is very expensive, very expensive. Casting is rough, so again you need to do machining. And milling, it is very slow process. You have to do one by one. Then there are other machining processes like gear hobbing, gear shaping, gear lapping, gear generating. But these are all machining process, and again they take little more time than your forging. So nowadays, if you visit Mahindras, earlier they used to produce the gears by gear hobbing or by gear shaping. I am not talking about normal shaping machine, I am talking about gear shaping machines. So now those are replaced. Those are becoming obsolete because nowadays they manufacture gears by forging. Nowadays मतलब 3-4 साल पहले से ही, so they forge, so it's very fast. These are the tubes which are used for toothpaste or your, what do you say, cosmetics. So this is done by impact extrusion. मतलब थोड़ा हम लोग एक slug लेते हैं और we take a small shot of solid material which is placed in the die, and then it is impacted by a ram, so that you get that. This is what is your impact extrusion is. So this is a blank. Blank is nothing but the raw material. Okay. This is a stripper plate. Stripper plate is used for ejection. And then you have a punch which is going down. This is what the punch is. Punch approaches work at a high velocity. And then as depending upon the shape of the cavity, the part will be formed by the impact. Now you have to remember that you have to design a punch in such a way, punch and cavity. See, this is a punch and this is a cavity. So punch will be designed as per the internal shape and cavity will be designed as per the external shape. At the same time, you have to design punch in such a way that when punch is going up, आपका जो component है, that will come along with the punch. That means it will stick to the punch. It should not remain in the cavity. That is what you have to see. So how you will achieve this? For this, you have to make punch slightly rough. Slightly rough का मतलब ऐसा नहीं है कि it will have scratches or it will have grooves or it will have threading kind of thing. Slightly rough, sir. Whereas cavity will be एकदम तुलतुलित. तुलतुलित mean understand like a clean shaved face. एकदम clean shave face कैसा रहता है? Like that, cavity will be there, so that the component doesn't sticks to the cavity. Since it is mirror free, mirror like finish, that component will not stick to the cavity, and since the punch finish is comparatively coarser than the cavity, आपका जो component है that will stick to the punch and it will move up along with the punch. Okay. And then moment the punch go up, the component also goes along with that punch, and there is a plate which is called the stripper plate that gets activated, and that stripper plate pushes the component so that it gets ejected. Okay, of course there has to be reasonably good amount of clearance between your die and the punch. Otherwise component will not fall properly. तो वापस वो कैविटी में जाके बैठ जाएगा. So like suppose if this height of the component or the length of the component is 50 mm, then आप punch 100 mm ऊपर उठाओ, so there will be a clearance of 100 mm between die and punch, and now you activate the stripper plate, so the component will get ejected properly. So stripper helps in ejecting out the component. Okay. Many times there is a practice that in case if the component remains in the cavity, then that is if you are not using stripper, then the peoples they remove the component manually. Manually वो लोग निकालते हैं. Of course with the help of a gloves. Okay, the component is in hot condition, and if you just try to remove the component with your naked hands, then your hands will get burned. So you should be careful. You matlab the operator has to be careful. Cold extrusion, like this is your cold extrusion. This is a die and this is a punch. Okay. Generally the die is at the bottom and punch is at the up. Okay. And this is what you are going to get a shape when your punch descends down. All right. And now the punch has gone up. Now here the component, there is no way that the component can be moved away or can be moved up with punch. It's not possible, isn't it? Because there is no depth and it's a shallow component. So the component will obviously going to remain in the cavity itself. So there is a ejector rod which is coming from the down. So when the punch goes up, and whenever there is a sufficient clearance between cavity and punch, like suppose if this height is 50, so as soon as the punch moves more than 50 mm up, this ejector is activated. This is all this mechanism has not shown. There is a part of the press. There is a part of the press. So moment punch goes sufficiently high, this ejector rod gets activated. It's pushed from the bottom so that component है वो ऊपर आ जाएगा. Okay. Only the problem with using this ejector rod is, since the component is in hot condition and you are using ejector rod to push, so there is a contact of ejector rod and the component. So you get a mark of ejector rod because it's in the hot condition. So you get a mark of ejector rod. And if it is not accepted aesthetically, then you cannot go for such kind of ejection system. That time you have to use stripper. So the ejector rod is going to give you a mark. And the peoples who are into die design, if they look at the component, they can easily identify ये component का injection point कहाँ पे है, that is getting, and ejection point कहाँ पे है, from where the component is ejected and how the component is injected. Because looking at the parting line, looking at the get mark, looking at the ejector rod mark, experienced person can very well understand. Hydrostatic extrusion, everything remains same, only the pressure of fluid is used, usually oil. So there is a difference between extrusion and drawing. In extrusion, the material is pushed, whereas in drawing, the material is pulled. So try to understand this pushing and pulling. Okay. Pull matlab खींचना और push matlab दबाना. So this is what is your drawing is. What you can see, that's your drawing operation being done here. So you have a pulling force here. Then this is metal which is being drawn. and this is called as a die. This is most likely and most popular question in the examination, difference in extrusion and wire drawing. So here you have pushing force, here you have pulling force. Extrusion, you have seen that it can create very complex cross section even with the hollows, whereas wire drawing it is mostly for the wires, round wires. Wire drawing generally it is most of the time it is cold wire drawing only, whereas extrusion can be hot and cold. Then these are the materials like aluminum, copper, steel, magnesium. This can be used for extrusion. And for wire drawing, generally we go for non-ferrous material, like aluminum. Of course, you can also go for ferrous also. There are defects in extrusions. Like we have seen defects in casting, defects in forging. So similarly, you have defects in extrusions. Out of this, defects in casting is important from, all are important, but casting defects are important from examination point of view. That is a popular question of the examiners. So you can have surface crack and you can have internal crack also. So the internal cracks mainly because of the blow or mainly because of the voids or because of the hollows. Surface cracking because of the friction or because of the speed, because of the sticking. Because whenever the material sticks, its pressure will increase and product will stop flowing and again it will start moving. So that will lead to crack. Start stops. Crack कभी भी कभी होएगा whenever there is a differential temperature, differential pressure. Outermost जो surface है it is at higher temperature, अंदर का surface है it is at lower temperature, and there is a sufficient time lag for the heat to pass. So obviously this will lead to crack. So that's why if the pieces are thick, like suppose if you have taken a glass, okay, there are two glasses. Now this is a question for you, aptitude question. There are two glasses, okay. एक का ग्लास है 5 mm थिक बॉटम, दूसरा का जो ग्लास उसका जो बॉटम है दैट इज ओनली 1 mm थिक. अभी दोनों में हम लोग हॉट पानी डाल दिया, गर्म पानी at say 100 degrees Celsius. तो which one will crack? जिसका थिकनेस एकदम मजबूत है दैट इज 5 mm वाला और जिसका थिकनेस 1 mm है. बोलो पीटर.
5 mm.
5 mm थिकनेस वाला will crack. Perfect. Because I told you difference in the temperature. ऊपर 100 है और नीचे रूम टेम्परेचर है. Whereas so that heat is not passed quickly. Whereas जिसका की बेस का थिकनेस 1 mm है, where the heat is passed quickly. Okay. So there will not be any distortion, or this is a typical question asked in FT. इधर गया. So in order to reduce the friction, this lubrication is very important in extrusion, because it affects material flow, it affects surface finish, it affects product quality, etc. Wet drawing matlab you are using with the help of the lubricant. Dry drawing matlab there is no lubrication, so friction will be more, the forces requirement will be more. Alright, so this is a flow chart. Like you have received bar material, you inspect the bar material, cut koro, then ये billet है, then this is being passed through the, this is a rolling process, or piercing process also. So piercing process, this is what is used for, you know, generating the hollow inside where the rod passes. So ऊपर से ऐसा दो रोल है. So this is what is your push extrusion. So the rod is passing. Okay, either the feed is given to the rod or the feed is given to the billet, okay, which is passing between the two rollers. Generally the feed is given to this component. Okay, ये जो rod है उसको stationary रखते हैं so that the hollow will be created. So even the outside and inside can be done simultaneously, right? Can be done simultaneously. Then I wanted to discuss about this metal casting. I think this I have not low uploaded. मतलब PPT I have uploaded. Yeah, this is the same. This I have uploaded already. Then another longer chapter is joining processes. Joining processes. So joining processes can be divided into mechanical joint and fabricated joint. Fabricated matlab not necessarily welding, use of welding. Even nut bolt, that is also called as the fabrication. But most of the time fabricated is considered like welded components. Okay. Joining process matlab the processes which are used for joining. So you can use nut and bolt, you can use welding, you can use brazing, you can use soldering. There are many processes. Riveting. So every process, it has its own advantages and disadvantages. So here, like say mechanical joints. So what are the mechanical joints? You have bolted joint. Now this is what is your bolted joint is. Now 90% or sometimes I am sorry to say 95% students, they make a mistake in bolted joint. Now here these are the two blocks which are to be joined, that is one is blue color and another is green color का block join करना है. Alright. The first mistake what they do, that they show threading इसमें भी और इसमें भी. No. Threading has to be only in one piece. एक में ही थ्रेडिंग रहेगा, दूसरे में थ्रेडिंग नहीं रहती है. ये जो दूसरा जो प्लेट है उसमें देयर इज अ फ्री होल ऑलवेज. लाइक सपोज इफ दिस इज M10, लेट अस कॉल दिस एज अ M10 bolt. Again, many of the students, they fail to tell what is M10. M stands for metric and 10 stands for the diameter of this bolt. Generally the threads are designated like this, M10 by 1. So 10 mm is the diameter of this bolt and 1 mm is the pitch. Pitch is nothing but the distance between two consecutive crests or trough, or technically the pitch is defined as the distance moved in one revolution. Like suppose if I rotate this nut in one revolution, then it is going to move axially if my bolt is stationary. Whichever is not stationary, that is going to move. Whichever is stationary, that will not move. Obvious. Okay. So अगर यहाँ पे अगर मेरा bolt stationary है and if the nut is free to move, then obviously nut is going to move axially. So 1 mm pitch का मतलब अगर मैं nut को एक राउंड घुमाऊंगा, so it will move by 1 mm distance, axially 1 mm distance. That is what is for the pitch. So the first is you have to remember that thread you have to show only one plate, and if this is M10 bolt, then you have to have a free hole here in the second plate, at least 11.5 ka clearance. So these are the two things you have to remember. Okay. So in your assembly drawings, you have to show that threading in one piece and free hole in other piece. So there will be two lines in this plate. For the threading, there will be two lines. There is a convention to show the threading. Then this particular thing is called as the nut, and this is washer. Earlier we used to use washer separately and nut separately, so that used to consume lot of time, assembly time. But nowadays the nut and washer comes as an integral unit, and they are called as the combination washer, combination nut and washer. Combination nut and washer का मतलब है the washer is permanently fixed to the nut. It is forged together, nut as well as washer. So your assembly time is saved. As your assembly time is saved. Okay, so we will, sorry, I think it's time. We will continue tomorrow. We will stop now. Okay, so thank you.
Bye, sir. Thank you, sir.
Yeah,
Thank you, sir.
welcome.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you.
Thank you, sir.